Okay, 8.5, part 2. So we're still talking about logarithms and logarithmic expressions. Now we're going to start talking about condensing a logarithmic expression instead of expanding. So the opposite of expanding is condensing. So we are going to take a logarithmic expression. So in this case, we've got log of 3 plus 3 log of 2 minus log of 6. And notice that they are all common logarithms, so in other words, it's log base 10. So they all have the same base. That base is 10. It's assumed, which is why the base isn't written as a subscript underneath the log. So we start off with this, and because it's the opposite of expanding, we're going to do it in the reverse order of expanding. So instead of starting with the quotient property, we're going to end with the quotient property. Instead of ending with the power property, we're going to start with the power property. So remember, the power property says that, well, let's see, for example, okay, so for the power property, if we have log base 3 of x squared, that's the same as saying 2 times log base 3 of x. So in other words, the exponent becomes the coefficient in front of the log. So if we're going to be doing the opposite of that, okay, so we're going to reverse that. So that means we need to look for things that have a coefficient in front of the log. And the only term that has a coefficient in front of the log is this middle term. And we have a coefficient of 3. So we're going to take that 3 and we are going to put it back up where it obviously was originally, which is as an exponent on the 2. And I will rewrite that as log of 2 to the third power. Okay. So the next thing we look for are any instances of product property. And remember, the product property was if we had, well, let's say log base 3 of 2 times 3. Okay, that's the same as log base 3 of 2 plus log base 3 of 3. Okay. So we're doing the reverse of that. So now we look for sums. Well, I have a sum of log of 3 and log of 2 to the third. So that would be the log of 3 times 2 to the third. Okay. So eventually I'm going to have to use my order of operations and take care of that term first. All right, and then the last thing I'm going to do is the quotient property. And for that, I look for differences. Well, the only difference that I have is this term, log of 3 times 2 to the third minus log of 6. And remember, so instead of the product power or the product property, this is the quotient property, so I'm going to divide those terms. So 3 times 2 to the third over 6. And so now I simplify everything that I can. And so I'm going to wind up with log of, well, 2 to the third is 8, times 3 is 24, and then 24 divided by 6 is equal to 4. So we just have log of 4. So all of that just to get log of 4. Finally, the last thing that we are going to talk about in 8.5 is what's called the change of base formula. So this allows us to convert, uncommon logs to either logarithms, common logarithms, or natural logarithms. So in other words, getting rid of some random base c, like if it's a base 2 or a base 6 or something like that, we can convert that to either a common log or a natural log. And so what happens is you change the base to whatever you want and then take the target of the original, and that goes in the numerator, and the base of the original goes in the denominator. So specifically, if we want to convert it to a common logarithm, in other words, log base 10, it would be log of u over log of c. And if we wanted to convert it to the natural logarithm, it would be ln, or natural log of u over natural log of c. And that's pretty much it. So you can use that now to your advantage if you have a scientific calculator that doesn't allow you to plug in whatever base you want. Almost all scientific calculators can handle either the natural log or the common log, log base 10. So we'll start with common logarithm. So we're going to convert it into the common logarithm, log base 10. So I start off with log base 5 of 6, which we would then just convert to log of 6 over log of 5. Okay. And if we really wanted to, we could indicate that this was log base 10, since we are doing change of base. Log base 10 is just the common log, so log of 6 over log of 5, and then I can approximate that on the calculator. Log of 6 is approximately 0.778 over the log of 5, which is approximately 0.699. And when you do that on the calculator, you get approximately 1.113. Okay. And you can do the same thing, and basically this is just proving it by using natural logarithms now. So we're going to do the exact same problem, except now we're going to convert to natural logarithms. So in other words, log base e of 6 over log base e of 5, which is just the natural log, so ln of 6 over ln natural log of 5. And again, the natural log of 6 this time is 1.792 over the natural log of 5, which is 1.609. And if you punch that on the calculator, lo and behold, you get 1.113. Okay, and that's the change of base formula. And that takes care of 8.5.